Hello there, Mr. Sutton here, bringing you the IM3 Quiz 2 Extra Practice Answers on Advanced Factoring. For this one, we're trying to simplify something in the form a minus b squared. So for that, we're going to use our form a squared minus 2ab plus b squared. So for a squared, we're just going to square this first thing here, 7x. So if I square that, that's going to be 49x squared. And then for 2ab, I have to multiply these two things together and double it. So 7 times negative 2 gives me negative 14x. Doubling that, I get negative 28x. And then finally, for b squared, that's going to be 2 squared that I'm adding. So that's going to be plus 4. For this problem, I'm multiplying conjugates, a plus b times a minus b. So my answer is always going to be in the form of a squared minus b squared. So for a squared, I have to square 4n. That's going to be 16n squared. And for b squared, I have to square 6, so I'm going to be subtracting 36. For this problem, I'm trying to factor this trinomial. Now I notice right away that my a value here, my squared coefficient, does not equal 1. So immediately, I try to factor out common factors if I can. Unfortunately, 9 doesn't have common factors with the rest of these coefficients. So we're going to have to move on to other things. I see here that we have a perfect square sandwich. 9m squared is a perfect square, so is 64, and there's something in the middle. So I can try one of my shortcuts before using the AC method. Specifically, this might be one of those perfect square trinomials, so I can try the shortcut a minus b quantities squared. I don't know if it's going to work until I try it, but it's worth trying because this is a lot of work if you use the AC method. So for a, I need the square root of 9m squared. That's going to be 3m. And for b, I need the square root of 64, which is 8. And I'm going to be subtracting 8 because my middle term here is negative. So this is 3m minus 8 quantities squared. Now let me double check just to make sure that that actually works. To do that, I have to multiply these terms together and double it to see if I get this middle term of 48m. So 2 times 3m times negative 8, what does that come out to? 2 times 3m is 6m. 6m times negative 8 is negative 48m. Since that matches the middle term I started with, that means this answer, 3m minus 8 quantity squared, is in fact the actual answer. For this problem, I'm trying to factor this trinomial, and I notice that my a value out here, the squared coefficient, is not 1. So let me see if I can factor out that 2 there. Unfortunately, although 20 is divisible by 2, 3 is not. So I can't take out a common factor. And I don't have any perfect squares on here that I could use a shortcut for. This is not one of those special factoring situations. So that means all that's left is the AC method or guess and check. I'm going to use the AC method. So to start that, I will multiply the a and the c value together. 2 times negative 20. That gives me negative 40. And now I'm looking for factors of negative 40 that add up to negative 3. So I've got 1 and 40, that's not going to do it. 2 and 20 doesn't work. 4 and 10, it's not going to work. How about 5 and 8? If I had positive 5 and negative 8, that would add up to negative 3. So I'm going to split this up then into plus 5r minus 8r. That's the only change from what I started with, just splitting up that middle term. And now that I have 4 terms, I'm going to factor this by grouping. So for my first 2 terms, I'm going to factor out r. That leaves me with 2r plus 5. For my next 2 terms, the last 2 here, I'm going to factor out negative 4. That leaves me again with 2r plus 5. Then I'm going to factor out 2r plus 5 as a common factor. And that leaves the leftovers here, r minus 4, in a parentheses next to it. And now this is fully factored. To factor this trinomial that has an a value that is not 1, I first see if I can take out any common factors. Specifically, negative 4 would be a good one to try. And it looks like all these coefficients are divisible by negative 4. So if I factor out that negative 4, I'm left with a p squared plus 6p plus 8. And now for the stuff inside, my a value inside, the coefficient of this p squared is just 1. So this is one of the easier factoring cases. I just need to find factors of 8 that add up to 6. So 1 and 8 is not going to do it, but 2 and 4 would do it. So I can split this up, bringing down this negative 4 into p plus 2 and p plus 4. For this problem, trying to factor this difference of perfect squares, it's awfully tempting to just square root things and use the form for this. However, we've got to be careful. You should always check to see if you can take out a common factor first, because if you can take it out in the beginning and you don't, you're going to have to do it later on, and it's usually tougher if you wait to do it. So right away, I see I can take out a common factor of 4. That leaves me with m squared minus 25. And now I have another difference of squares in this parentheses that I can proceed to factor. This is essentially a squared minus b squared, and we know that the factorization for that has the form a plus b times a minus b. So I just have to square root these two things to get a and b. So bringing down the 4, square root of m squared is just m. Square root of 25 is 5, so I have m plus 5 there. And I have another factor of m minus 5. For this problem, trying to factor this, I notice that my a value out here is not 1. So let me see here. If I can take out a common factor, that would be the best case scenario. But it doesn't look like there's any common factors I can take out between 9, 65, and 14. Next, I look for perfect square sandwiches. 9n squared is a perfect square, but 14 is not. So I can't use any of those special factor or special product kind of shortcuts. So all I can do now is the AC method or guess and check. And since 9 and 14 both have multiple factors, I'm thinking the AC method is going to be a little bit faster. So let me start by multiplying 9 and 14 together. That's going to give me an AC value of, well, let's see, 9 times 10 is 90, 9 times 4 is 36, 90 plus 36 is 126. So now I need to find factors of 126 that add up to negative 65. And I know the factors will both be negative because they multiply to give me a positive and they add up to a negative. So they have the same sign and adding them gives me a negative. So they're both negative. Now, if you're worried about finding factors of 126, don't sweat it. Let's just start at the beginning and see what we come up with. So we have 1 and 126. Clearly, that's not going to add up to 65. How about 2 times something? Well, this would be 2 times 63 to get 126. And if I had negative 2 and negative 63, well, that would add up to negative 65. So for my next step, I'm going to split up negative 65n into negative 2n minus 63n. And now that I have 4 terms, I can factor by grouping. So for my first 2 terms, I can take out an n from that, leaving me with 9n minus 2. For my last 2 terms, those are both divisible by 7, negative 7. If I take a negative 7 out, we've got a 9n minus 2. Now that I have the same parentheses, 9n minus 2, I can factor that out from everything, leaving me with n minus 7 in a parentheses next to it. For factoring this problem, I notice that I have a difference of 2 squares and I can't factor out any common factors. So if I have a squared minus b squared, that means my answer is going to have the form a plus b times a minus b. A in this case is going to be the square root of 49x squared, so that's 7x. B is going to be the square root of 100, so that's going to be 10. So we have 7x plus 10 times 7x minus 10. For this problem, trying to factor this trinomial, I notice I have an a value that does not equal 1. So right away, I'm going to try to take out a common factor to see if I can make my life a little bit easier. Now, between 3, 30, and 75, 3 is the greatest common factor. If I take a 3 out, that leaves me with x squared plus 10x, and 75 divided by 3 is 25. Looking at what's inside now, you could factor this just by asking what multiplies to 25 and adds up to 10, or you could view this as one of those perfect square sandwiches whose solution has the form a plus b squared. A would be just the square root of x squared, which is just x, and don't forget to bring down that 3 as well, right? So we have an x, and then b is going to be the square root of 25, which is 5. It's going to be a positive 5 because this middle term here is a positive. So we have x plus 5 quantities squared. And if you do use this shortcut, rather than simple, factor versus sum kind of reasoning, just make sure you double check by multiplying these together and doubling it to make sure you get 10x. So 2 times x times 5, basically 2ab, that does give us 10x, just like we hoped. So 3 parentheses x plus 5 squared is the answer.